when we look at binomials, I'm thinking about things with two terms, right? Now, that was when I was looking at expanding. Afterwards, in mathematics, we always kind of look at things in pairs of things, right? I look at addition, then I look at subtraction, I looked at multiplication, then I looked at division. And then after we look at expanding, we want to look at factorising, because it's the kind of opposite operation, right? What's actually involved here, though? Really, when we're looking at factorising, I want you to think about two things. Look for what's in common, and then think about how you can introduce brackets, okay? Because if you think about a very simple example, right? If you think about expanding 2 outside of x plus 1, okay? How do I expand this? Well, what am I actually doing? I multiply everything on the inside by the outside, right? That's actually what expanding is. And so you get 2x plus 2, okay? That's what expanding is. The question is, how can I factorise and go backwards? Well, really, you say, hang on, what's in common here? Well, there's both 2's. I can factorise them out, and then you get left with x plus 1. What you're actually doing, you may not think about it, but what you're actually doing is you're dividing both of these by 2, and then you're taking that out. Does that make sense? Can you see that? That's all I want you to think about when you're factorising. And we can look at some simple examples, and we'll move on to some tricky ones, right? For this one, all I'm thinking about is what's in common. I can see I've got a 3 and a 12, so I can see there's a factor of 3 which is in common, right? So I'll take that factor out. What will I get left with? Well, really what I'm doing is I'm dividing this by 3, so I just get left with a single x, and then 12 divided by 3, that's just 4. That's right, okay? What's one way you can actually check this? Expand it back out, right? If you expand it back out, you would just get 3x plus 12. You know that you haven't changed anything. So the same idea with simplifying, right? You're not changing anything. You're just kind of rearranging it in a way. But what are you doing exactly? You're looking for what's in common, and then you're introducing brackets, okay? Even when you just have strange algebraic expressions, you can still see what's in common here, right? Did anyone see what's in common with the second? Y is in common, right? Even though there are no numbers in common, there is a factor of y which is in common. And so always think about introducing brackets, and just think about what you're actually doing when you're factorising something out. You're dividing by y, right? So if you take out a factor of y from y squared, I'm going to get left with just a single y, okay? Because if you do y times y, that gives you y squared, and then I have minus 2. Yeah, see that? Right. Sometimes year 10, it may be even more than a single factor of that variable. Can anyone see what's in common with this next one? Good, right? Can you see here? I've got x cubed minus 2x squared. There are no numbers that are in common, so I won't take any of those out. But I do have x squared, which is in common. So same idea here, I'm just thinking about what I have. I've got x minus 2, okay? And again, I can check that really easily. If I expand that out, I'd get x cubed. If I expand that out, I get minus 2x squared. Really all you think about, just think about what's in common. Okay, I know there's x squareds in common. And I'm taking it out, I'm dividing by that term. Okay, can you guys see that? It's a slightly different idea, okay? But that's what we're doing at the end of the day. It's the same principle as these easy ones. But we're just using it for some algebraic variables too, okay? How do you feel about that? Not too bad? Yeah? Okay. Now, when we get to something like this seems like, okay, whoa, what is going on here, right? It's so long, it's a very big expression, but always come back to these two things. We look for what's in common, and then I introduce brackets. Can anyone see what's in common here? Yes, all right. Now, that seems like strange. Am I allowed to do that, right? I've seen that there's a 3 in common, there's a y in common, even x squared in common. And x plus 3 in common, what would that look like? Well, let's try it. Let's take out that x plus 3 first. Okay. Now I'm going to do slightly different brackets here, just to show you what's actually happening. When you take out something that's in common, right, what you're actually doing is, think about what you're doing, you're dividing, okay? If I take out x plus 3 from this term here, what do I get left with? 5, right? Because this is just 5 multiplied by x plus 3. And then what would I get left with here? I get left with 2y, right? Because this is just 2y times x plus 3. And that's it. Okay. I've just drawn the square brackets there because, I don't know, it can be sometimes a bit confusing what I've actually done here, right? All I've done is I've looked at these two terms separately, and I've said, I'll take out that x plus 3, I get left with 5. And I take out the x plus 3 in there, I get left with 2y, okay? That's all I'm doing. I'm still looking for what's in common, and I'm still introducing brackets. And you can do the same thing with this one here. It doesn't matter what those expressions are. As long as you can find what's in common, you can factorize those out. So, again, with this one here, Matt, do you want to help me out? What's in common here for this one? Just M? This one here? What's in common? M. Oh, wait, I wrote it wrong. That is not fun. That's bad. Sorry, guys. That should be M plus 5. Well, one of them should be the same. My bad. So again, right, looking for what's in common. There wasn't anything common before, but now there is. Right, I'll take out that M plus 5. And then same idea. What do I get left with? Well, I just get left with what expressions are there? 2x plus 3, exactly. Yeah. Any questions on what I did there? Again, I'm always thinking about factorize, look for what's in common, introduce brackets. Okay.